Hello and welcome to another exciting math video. In this video, we're going to start section 4-3 dealing with right triangle trigonometry. Our bullet points, we will evaluate trig functions for the acute angles, use some fundamental trig identities, and use trig functions to model and solve real-life problems. All right, first, here are the 6 trigonometric functions. This section introduces the trig functions from a right triangle perspective. Consider the right triangle shown below, in which one acute angle is labeled theta. Relative to angle theta, the 3 sides of the triangle are the hypotenuse, the opposite, and the adjacent side. So down here at the picture, here is angle theta down in this corner. And from angle theta's perspective, the opposite side is over here. Notice that angle theta is not touching the opposite side. We have an adjacent side that is touching angle theta, and the hypotenuse is always the hypotenuse. It's across from the right angle. So again, the hypotenuse is going to be the hypotenuse no matter what. But what if we changed our angle's perspective? I'm going to call this angle up here theta prime. Now, theta prime's opposite side is this side, which is the adjacent side to this angle theta. And the side adjacent to this theta prime is the opposite side from theta. So again, this is all a matter of perspective from what angle we are looking at. What side is opposite and adjacent. Again, the hypotenuse is always the hypotenuse. And down below, we have our trig ratios. Sine of an angle is the opposite side over the hypotenuse. Cos of theta is the adjacent over the hypotenuse. Tan of theta is the opposite side over the adjacent side. Right below these are the reciprocals. If we take sine opposite over hypotenuse and flip it over, that is our cosecant of theta function, hypotenuse over opposite. If we flip over cosine adjacent over hypotenuse, it becomes secant, hypotenuse on top, adjacent on the bottom. And tan is opposite over adjacent. If we flip that over, we get the cotangent of angle theta. So if you memorize sine, cos, and tan, and then just which ones are the reciprocals, you'll have all 6 of these down pat in no time. And how do we memorize sine, cos, and tan? You might remember from geometry, good old SOHCAHTOA. So here's how I saw it written when I was in school, SOHCAHTOA. I started writing it like this. Sine is opposite over hypotenuse. There's so. CAH, and then TOA. And a little mnemonic to memorize this. Some old hippie came a-hoppin' through our apartment. Some old hippie came a-hoppin' through our apartment will help you memorize the 6 trig ratios. And then if you know how to flip them over, you'll get the other 3 for a total of 6. Okay. It says let angle blah blah blah. Okay, this is the same thing we saw here. These are our definitions of the 6 trig functions, and we have the abbreviations op, adjacent, hypotenuse. And remember, these are all a matter of perspective from angle theta. All right, let's try these out. Use the triangle shown in the figure to find all 6 trig functions of theta. So when I look at the picture, we've got the 2 sides here. We are missing the hypotenuse. And let's see here, Pythagorean theorem says a squared plus b squared, those are the 2 legs. Those will be equal to the hypotenuse, which is c squared. So this becomes 9 plus 16 is 3 squared plus 4 squared. That is 25. That's equal to c squared. If we take the square root, we're going to get 5. Now, if you're thinking plus and minus, remember we are dealing with a length here. From this point to this point, we cannot have a negative length of a side of a triangle. So the negative makes no sense. We throw it out. C is 5. So I'm going to come up here, cross out hypotenuse. This is 5. So we're going to find all 6 trig functions. Sine, cos, that's a terrible S, sine, cos, and tan from angle theta. Well, let's see. Sine is opposite over hypotenuse. So here we are at theta. Opposite side would be 4. Hypotenuse side is 5. So that becomes 4/5. Cosine is adjacent over hypotenuse. So here from angle theta, the adjacent is 3. Hypotenuse is 5. 3/5 is the ratio we're looking for. And then tangent is opposite side, 4, over adjacent side, 3, 4/3. Now that we've got the first three, we can find the reciprocals, cotan theta, secant theta, cosecant theta. And I wrote them like this because sine and cosecant are reciprocals. If sine is 4/5, cosecant is 5/4. Cos and secant are reciprocals. If cos is 3/5, secant is 5/3. Just turn it upside down. Tan is 4/3, so that means cotan is 3/4. So there are all 6 trig functions from angle theta's perspective. And what's next? Here we got a special triangle. You might remember from geometry a 45, 45, 90. So here's the triangle in drawing. We got our side lengths are 1 and the hypotenuse is √2. Angles are 45. So if we want to find the sine of 45 degrees, we can either go from the perspective here, I'll hit this one in red, or this one in blue. It doesn't matter, you know, what angle we use because they're both 45. Sine is opposite over hypotenuse. If we go from the blue angle here, opposite is 1, hypotenuse is √2, and that's the same if we go from the red 45-degree angle. Opposite is 1, hypotenuse is √2. So this is 1 over √2. Now here in pre-calc, we do not leave radicals in denominator, so we are going to rationalize. We're going to multiply top and bottom by √2's. Where did my red 2 go? There we go. So if we multiply straight across, we're going to get a √2 in the numerator, a √4 downstairs, and the root of 4 is 2. So the sine of 45, square root of 2 over 2. The cos of 45 degrees. Remember, cosine is adjacent over hypotenuse. And from this angle's perspective, adjacent is 1, hypotenuse is √2. From the blue 45, adjacent is 1, hypotenuse is √2. So this is just going to be 1 over the root of 2 like we saw for sine. And when we rationalize, square root of 2 over 2. Let me point out one more time. You've probably heard me say this before. The cofunctions of complements are equal. Cofunctions of complements are equal. Well, sine and cos are cofunctions. Sine, if you put a co on it, you get cosine. If you got cos and you chop off the co, you're left with sine. So sine and cosine are cofunctions. And if the angles are complements, 45's complement is 45, so they add up to 90 degrees. So those values should be equal. They're both square root of 2 over 2. The last one we need to find is the tan at 45. Tan 45, tangent is opposite over adjacent. So here from the red one, opposite is 1, adjacent is 1. From the blue angle 45, opposite is 1, adjacent is 1. So that's 1 over 1, or just 1. Okay. A couple practice problems for you. So pause the video, solve these problems, start the video back up, and see if you got them right. Okay, for this one, first thing we need to do is find the missing side. A squared plus b squared equals c squared. Remember, a and b are the legs. One of our legs is 2. We'll make that a. We don't know the other leg, so we'll call that the b. And then our hypotenuse c is 4, 4 squared. So 4 plus b squared equals 16. Subtract 4 from each side. B squared is 12. So we take the root. B is the root of 12. And remember, 12, we could write that as the root of 4 times the root of 3. And the square root of 4 is 2, so that's going to be 2 times the square root of 3. 2 root 3. So there's our missing leg of this triangle. And I'm just going to put this out of the way up here. And make this a little bigger, I guess. Here's our angle theta. So this 2 root 3 is the adjacent side. And it wants us to find, I think, all 6 of these, right? Yeah, find all 6. So I like to set it up like this. This is how I have them memorized. Sine, cos, tan. And then I go to cotan, secant, cosecant. Okay. Sine is opposite over hypotenuse. Some old hippie. Opposite is 2. Hypotenuse is 4. So that is 2/4 or 1/2. Now that we've got sine, let's flip it over to get its cosecant. 1 over 2 flips to 2 over 1. Up next, cosine. The hippie came a hoppin'. Adjacent over hypotenuse. So this, our adjacent is 2 root 3. Hypotenuse is 4. And notice the 2/4, we can reduce that down to 1/2. So that's going to be a root of 3 over 2. To get the secant, we're just going to flip that over. So that's going to be 2 over a root of 3. And let's rationalize. Multiply the numerator by a root 3. Multiply the denominator by a root 3. And the radical disappears. So 2 roots of 3 over 3. Finally, tangent. Tangent is opposite over adjacent. So that's going to be opposite 2 over adjacent 2 root 3. So that's going to be 2 over 2 root 3. The 2's cancel, so that's a 1 over root 3. And if we multiply by the multiply by root 3 over root 3 to rationalize, we get the square root of 3 over 3. Now when it comes to cotan, we are going to flip it over, but let's flip over the 1 over root 3. Because if we flip over this final answer, we're going to just have to rationalize again. So if we flip over the 1 over root 3, we get the root of 3 over 1. And there's our final answer for that one. Okay. Now, this one, it says find the cotan and the secant and the cosecant of 45. Well, remember in that earlier example, we found the sine of 45 was 1 over the root of 2, which we rationalized to the square root of 2 over 2. This is back, yeah, I still got it right here. I should have just flipped back to this. Okay. Sine of 45 is 1 over root 2. So to find the cosecant of 45, we're just going to flip this over. And let's flip over the one before we rationalized. 1 over root 2 is going to flip to root 2 over 1. The secant of 45 is the flip of cos. Well, we found the cos at 45 was also 1 over root 2. So we're going to flip that 1 over root 2 over into root 2 over 1. Again, these are both the same. Now cotan 45, that's the flip of tangent. So if I come back here, tangent was 1 over 1. So cotan is also going to be 1 over 1. Or just 1. Okay, what's next? Number 3. Back here, we did a special triangle from geometry, a 45, 45, 90 triangle. Here's the other special triangle from geometry, a 30, 60, 90. So I'm just going to move this sort of down here so it doesn't take up too much room. It wants us to find sine and cos of 30 and the sine and cos of 60. So the sine of 30, cos of 30. Okay, here we are at the 30-degree angle from its perspective. Sine is opposite over hypotenuse. Opposite is 1. Hypotenuse is 2. So the sine of 30 is 1/2. The cos from that same angle's perspective would be adjacent over hypotenuse, or square root of 3 divided by 2. So that's going to be a root of 3. That's a terrible 3. Root of 3 divided by 2. Okay, let's move on to the 60s. I will switch to red ink, and I'm going to do my sine of 60 down here. You'll see why in a minute. And I'm going to do, ooh, yeah, my sine of, cos of 60 up here. What are you doing? Cos of 60. So now we're down here at the 60-degree angle. I'll highlight it in red. We are from its perspective. Cos of 60 is adjacent over hypotenuse. That's 1 over 2, 1/2. Sine at 60 is opposite over hypotenuse. Opposite is square root of 3 over hypotenuse 2, root 3 over 2. And I wrote it like this just to hammer home the fact again that cofunctions of complements are equal. Sine and its cosine. They are cofunctions. This angle is 30. Its complement is 60. Cofunctions of complements have the same value. They're both equal to 1/2. Here's sine of 60, and its cofunction, cosine, of the complement angle. 30 is complementary with 60. Cofunctions of complements are equal. They're both equal to root 3 over 2. Okay, what's next? Here's just a little table. Now this brings together the angles in degrees and rads. So here's sine 30, cos 30, tan 30, or also pi 6, sine of a 6 pi, cos of a 6 pi, tan of a 6 pi, 1/2, root 3 over 2, root 3 over 3. Next is 45. Sine of 45, cos of 45, tan of 45. Also the angles pi over 4 radians. And we have their outputs root 2 over 2 for the sine and the cos. Tan is 1. Finally, our 60-degree angle. Sine of 60 or sine of a third pi is root 3 over 2. Cos of 60 or cos of a third pi is 1/2. And the tan of 60 or a third pi is root 3. Notice here I'm going to point out a pattern. This will be helpful later. When we're looking at the outputs, we're going from 30 to 45 to 60. This could be the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2. We're also going to see that the sine of 90 is going to be the square root of 4 over 2. So there is a pattern. Root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. And we can also see that cofunctions of complements are equal. Here we see the sine, or these go down sort of in order, 1/2, root 2 over 2, root 3 over 2. Here it's reversed. 1/2 is at the bottom, and we work our way up to the root 3 over 2. All right. I believe this is our last example. Yeah, we'll do a couple huddle problems, and that'll be it for this one. The example says use a calculator to evaluate this angle. Now I showed you before how to convert degrees from minutes and seconds into decimals. Another way to do that, here we have 5 degrees. We're going to add to that 40 minutes, which is 40 out of 60 for our first decimal place. Plus we have 12 seconds. That's going to be 12 over 60 squared. Or you could just use the DMS to DD feature on the calculator, degrees, minutes, and seconds to decimaled degrees. And either way you compute it, this is going to be approximately 5.67 degrees. 5.67 degrees. Now, secant is not a button on your calculator, so we can't just push a button to get the secant of this, but remember, secant is the reciprocal of cos. Secant of theta is the same as 1 over cos of theta. So what we can do is do 1 over the cos of 5.67 degrees. 67 degrees. Now to type this in on the TI-30s, it's actually quite simple. You're going to make sure you're in degree mode, punch in your 5.67. You're going to hit the cos key to take the cosine of that angle. And then there's another button for reciprocals, the 1 over x key. When you click 1 over x, it's going to flip it over and divide that answer into 1. And then your final answer pops out of there. Yeah, 5.67, or oops. So if you punch that in, again, cos of 5.67, and then hit the reciprocal key, you're going to get approximately, I'm going to round this off, 1.0049 or 1.005. 1.005. Okay, a couple for you to try on your own. Tan of 60, tan of 30. So go back to that example in a couple examples ago with the 30, 60, 90. And then here find the cosecant of that angle. Okay, tan of 30, tan of 60. I'm just going to back up to that triangle. Here it is. So the tan of 30, remember the hippie came up and through our apartment, opposite over adjacent. So from 30 degree, opposite is 1, adjacent is root 3. So 1 over the root of 3, and we're going to multiply the numerator by a root of 3, and the denominator also by a root of 3. So root of 3 over 3. Tan of 60, now we're down at the other angle's perspective. But tangent is still opposite over adjacent, so that's going to be a root of 3 over a 1. Root 3 over 1 is just the root of 3. Okay. Now this one, first thing we're going to do is convert the degrees, minutes, and seconds into decimals. And that's going to be 34.51 degrees. 51 degrees. Again, cosecant is not a button on your calculator, but sine is. It's reciprocal. So we're going to find the sine of 34.51 degrees. And once we have that value, we're going to invert it with the 1 over x key. And I should mention, there's some other calculators floating around the room. You might see an x to the negative 1 key. Because remember, negative exponents move you to the denominator, so these would be equivalent. This is on the TI-30, and this is on the other calculators. I think they're blue ones. I can't remember what make they are. So we punch that in our calculator, 34.51. We hit the sine key and then the 1 over x key, and I'm going to round this off to approximately 1.7651. 7651. Okay, look for the assignment on WebAssign, and we'll do some odd problems next time we're together in class.